Hi, a lot of you've asked about how to use the more in-depth tools that come with Windows built in to do diagnostics and troubleshooting in case the kind of initial diagnostics I talked about weren't enough. And I mentioned them in my videos, so I'm going to cover them here. So the first thing to do is open a command prompt. So go down to the search, type CMD. You'll see command prompt come up. For this, we don't need to run as administrators, so you can just click on it to run it. I'm going to maximize it to make it a little easier to see. Okay. From here, the first thing we want to do is find out how our settings are to make sure they work or they're set up properly for our little network. So we just type ipconfig and hit enter. Now you look down here, it says that that's there, but there's no default gateways, so we know that's not the one. This is the one we're using, the WAN LAN or wireless LAN adapter Wi-Fi 3 in my case. We won't worry about the IPv6 stuff because that is not used at this level. The Windows, I discovered, doesn't think it has internet access if it has only IPv6, so we'll use the IPv4. So you'll see that it has the IPv4 address, and in my case it's 192.168.1.109. The subnet mask is a setting that determines which part of this is the network and which part of this is the individual machine's address. So kind of think of an apartment building versus the apartment specific itself. And in my case, it's 255.255.255.0. The default gateway that we're going to use is the IPv4 one, so 192.168.1.1. Now note, it hasn't told us anything about DNS servers. To get more information, you can go ipconfig /all, and that gives you a whole lot more information, as you can see. Okay, so it's for the same adapter. We've got a whole bunch of extra information, but we've got, the same thing, the base address, the preferred address, the subnet mask, because this one is obtained dynamically from what's called DHCP, or Dynamic Host Configuration Protocol. It tells us when that was leased out and when that lease will expire, so it only releases it for about 2 hours in this case, so it'll refresh before then. If it can't, then we have some issues. There's my default gateway. There's where the DHCP was got from. That can be information that's useful if you're getting in a really different or odd address that doesn't seem to make sense. You can see where you're getting it from. In my case, I got it from my main router. So that's a good thing. But occasionally something else will jump in and give an address. So the other piece of information that's in the advanced that wasn't in the basic information is the DNS server, which again, in my case, mine's not a very extraordinary case or whatever. It has the same router as the DNS server, which means it's acting as basically a DNS proxy. I talked about proxies in the other one. It basically acts as a go-between and goes out and finds the answers when you do a dynamic name system lookup and provides that back to my machine. Okay, let me clear the screen, CLS. Now that we have that information, the next tool to cover, and there's lots of other options for it. If you just type ipconfig and !, it'll give you all the options. But that was the main ones. Unless you're resetting or renewing your address, you can release and renew your IP address if you think you didn't get a good DHCP address. The same for your IPv6. If you think you got a bad DNS entry, you can do flush DNS. And then there's other stuff you can do that isn't even shown in here that lets us set and reset some settings in the system but that's again yet another more advanced video on resetting your internet IP stack. Okay, so back to what I was talking about. The next command would be an nslookup. Now that we know we've got the right settings, or we think we've got the right settings, let's check the functionality and make sure that conversion from a name to an address comes up properly. As you know, I like using google.ca, and I typed it wrong. nslookup www.google.ca, and it's going to go out and it's going to talk to, like I say, my router, which is going to go out and try to find the address. It's a distributed database, essentially, which means that there's a whole bunch of different machines that have individual pieces of the information. So there's a machine that's responsible for the .ca or the .com. Those are called top those are called top level servers, domain servers. But then what's below that is usually hosted on either a hosting provider, or if it's a big enough company, their own servers for domain name. If the local server doesn't have the answer, it'll contact the top level server, which will say, hey, here's the server that handles that domain, and it can go down to that domain and get the answer. So sometimes it takes popping around to a couple of different machines, a couple or 3 or 4 different machines before it gets a definitive answer. But in my case, it came back really fast. I'll show you a little trick. If there is a different server that you want to use, you can run nslookup in interactive mode. You just run nslookup with nothing else. And then you end up into this interactive mode. You can tell that by that little caret symbol. I'm trying to do that backwards. I'm not that coordinated. So now I can change the server to, let's say, 21650.24.3 or 192. Okay, so it's changed it to that. Now I'm going to try to look up Google. Uh-oh. It's timing out. Now you might see this if you have a DNS server that's set in there. And this would mean that your DNS client on your machine, software on your machine, can't access the DNS server. That can be an issue because then you won't be able to get the right IP addresses for any of the sites you're trying to bring up, whether that's in an app or a web browser or an email server or whatever. So that's one way that you can actually change servers and test servers and stuff like that. So if I set my server to 8888, which is Google's servers, okay, and then I go and do mine, boom, it comes back right away. Or if I change my server back to mine, and then I get the answer. Oh my. Did I do it wrong? Well, let's exit out, go ipconfig. I thought it was 0.1, maybe it's 1.1. Ah, it's 1.1, okay. That's why it wouldn't work. 1.1. There we go. So that's your nslookup command. Comes in very handy. Okay, now that we're done with the nslookup command, the next command would be ping. So once you can get an address for the name, and if the nslookup worked, you already know that your internet, at least to the DNS server, is working. So you can pick a host. We can do ping and to www.google.ca. And you can see it by default. It does 4 pings and it gives you various information. There's your 4 replies. So you know you sent pings out to it and it replied back. Because that's not on my home network or yours, then you know that you've got good internet access to that host. And it tells you about your latency and stuff like that. The minimum's 32, the maximum's 111, and the average is 66. The TTL is how many more hosts it could have gone through. There's 0% loss. You can see if you're losing data, etc., etc. Ping can also, instead of a host name, if your DNS isn't working, you can check your, well, let's try that bad address. You can use an IP address after it, and you can check with that. So, of course, that's not going to work. It doesn't exist on my network. So we'll just wait. This is the delay sometimes when you do try to bring up a host and it doesn't work, because it's going to try a bunch of times. Okay, so there we go. If I put a valid address in, it looks exactly the same as if I put the name in, except instead of having a name and then an address in brackets, it just has the address that you give. That's a very useful tool for determining if you can speak to a host, if it's up, things like that, if your network can get out to it. And when you're testing on the internet, so I could just say the same. I could say ping www.amazon.com, and there's my answer from that. The address doesn't look like what you put in here because it selects one of many different servers around the world that Amazon and Google and stuff like that use. And then there's the address, but it worked. Okay, so if we can clear out of there, the next tool to use is going to be traceroute, which is actually spelled traceert, T-R-A-C-E-R-T in Windows. I think they figured they needed to still follow the 8.3 naming convention from back in the 80s kind of thing. Anyway, it's actually on Mac if you're in a command prompt, or what do they call it, terminal window there, or Linux, etc. It's spelt out Traceroute, but it works exactly the same. So you can again put a name in here or an address. If I go 192.168.1.1, it's going to go out, and it's going to be a bit slow because without putting any options in there, it tries to figure out the name of the different hosts in between. Essentially what it is it does a ping to the host, changing that TTL, time to live, that I mentioned before with the ping, and it increases that. It starts with 1, 2, 3, 4, and then the host that at that time's out on will reply back, and it traces the chain. So let's try Google or Amazon. It doesn't matter. Tracert. Let's try Amazon.com. See where that one went from me. It may be quite a way. There is as it says, there's a maximum of 30 hops, and a hop is a jump from one router or machine to another. So we're not getting names back so far on these. Oh, now we're starting to get names. You can see that it jumped into Rogers, and it's going to go through, and you can see that it tells you kind of the ping statistics as it goes through. Those are very handy because sometimes you can find out where a delay is happening. So far I'm fairly quick through everything. That one was a bit high, and then it was low, and then it was high again. Now we're getting into some that won't reply. That one's just blocking it, essentially. Then it continues on, and obviously I'm not really close to the nearest Amazon server, so it's having to travel through a bunch of different networks to get there. And let's just keep our eye on what's going on. Anything else I can let you know. There are options, like I say, to keep it from trying to get a name. That tends to make it go a little faster through this, and I'll demonstrate that right after this. And again, while we're waiting on this, please like, subscribe, and comment below. Don't forget to hit the bell for notifications to find out when new videos are coming out. Now, in the meantime, well, we're up to 14. Looks like we've hit a black hole kind of thing, which can happen in some networks where you get so far and then the providers beyond that don't want to reply. We should, however, eventually get a reply, because we did before, from the actual Amazon host. There we go. It may not be the same one as we got before, but we got through. We found the path. We found the pings through there. That gives us a really good idea of how it works. That's a quick rundown of the 4 main tools that you can use in pretty much all those OSs to figure out how well your network's working and possibly where it's broken, especially with traceroute. If it goes a certain part of the way through and then nothing from there on, you've found where there's a problem in the network. And you can see, well, once it gets out of here, it's out of your network, and then you can kind of get an idea. A lot of times you get more names than this, so you get an idea where it's gone from your local ISP into other ISPs or networks on the internet to get to where it needs to go, and see where the problem's happening. A lot of times it's actually not you or your ISP, but sometimes it is, and this can help you differentiate the difference, I guess, essentially, which is what differentiate means. Okay, well, if you have any other further questions or you need further clarification, certainly leave comments below and I'll do my best to answer them. And if they're a big enough topic, I may actually make a future video about it. And I'm glad that you came and watched. Thanks very much. Have a wonderful day.